let's start this webinar. Good day to all of welcome to this webinar of the H2O'Lyon University Center. Today we'll listen Maxime Boivin. We'll listen to Maxime Boivin who will talk about deadwood in rivers and the experiments which have been made in the last 15 years in Quebec and organized together with the Lyon Collegium. H2O'Lyon every year will host one or two researchers for 5 to 10 months stay in Lyon together in partnership with the Lyon Collegium. This year we have Maxime with us until June and next year, and we'll have a second researcher, Santiago Yepes from Chile, who will join us in February. And this is also done in collaboration with the Réseau Rivière Network. So we've been working with this network for quite a while on thematics which concerns the various topics, and it follows a series of webinars we hold on deadwood in rivers and the low-tech restoration processes and techniques. And I will give the floor to Antoine, who will say a few words. Thank you for the organization of the webinar. And just to remind you that indeed it is a webinar organized for knowledge transfer between science and managers. And also it comes in addition to a long list of webinars for wood and rivers. And there is a playlist on the River Network website. And I give the floor now. Thank you. Thank you, Antoine. Now, maybe to set the context for those who might not know H2O'Lyon, it is a group of Lyon Saint-Étienne Research Labs group, and we are financed by the state, and we work on 4 pillars: link between training and research, education research, the link with the players in the territories, with the international players, and also we foster interdisciplinarity, which is essential for all the subjects and issues we deal with. We have a strong vocation for education and training, and we try as best as possible to invite and include students, master students or PhD students. So today, to co-facilitate the webinar, they will have Kirin Vical, who is a student in the Integrated Watershed Sciences Master for the Water Science department in Lyon, and he will do his internship in the RMC Water Agency to take stock of all the utilization of dead woods from rivers in France. So he will co-facilitate this discussion. And with no further ado, I'll give the floor to Kevin, who will introduce the Maxime, and then we'll leave the floor to Maxime. Kevin, you have the floor. So to introduce Maxime rapidly, he's a researcher specialized in hydromorphology at the Chicoutimi, Quebec University. He's been working for about 15 years and leading the research team dealing with geomorphology and especially wood dynamics in river and their interactions with river dynamics. And he's been involved in many research processes or project, and he has a guide of analysis for the analysis of wood in the river, and which is kind of a reference in French language for woods in river. And he has also a decision-making support tool intended to managers. So I'm sure we'll have the opportunity to discuss that later on. Thank you very much for your kind words of introduction. Now here's my presentation. Thank you all. Thank you for your participation. Thank you for your participation this afternoon or this morning for those who are in other time zones, especially in Quebec. And so thank you, H2O'Lyon, for allowing me to share my knowledge. I'm saying knowledge because when you work on a research project on site, there are usually a lot of participants, and I will try to pay a tribute to these collaborations. and I will do my best to describe 15 years of project in Quebec on the dynamics of woods in river. And there is a bit of France and Lyon in this project because I did my PhD in tutoring with Idée Perviel in Lyon 15 years ago. So we'll look at the various projects. And as Kevin said, I will also describe the guide we've developed together with colleagues from the uh, Quebec University, then two participants who are in the room are in the group. So on my side, I am a professor at the Université Quebec Chicoutimi for about 8 years now, more than 8 years. Professor in physical geography, specialized in geomorphology and hygromorphology, and I also work with the laboratory or the ERGA laboratory. I'm in charge with about 20 people within this lab. I do research on exploited halieutic species. We work on the restoration of rivers and the links between river dynamics and fish habitats. Sometimes I might speak a bit too much, so I'll try to stick to the 40 minutes. That's my goal, as Claire-Lise mentioned. I'm doing a research year in Lyon, hosted by H2O'Lyon and the Lyon Collegium until July 2026. The main objective is to work on the woods in river. We also work on the development of restoration of rivers and sediment transportation and so on and so forth. But we want to develop partnership, and I will describe some of the partnerships we'd like to set up in Lyon. The idea being to have fun in science between our two regions. So wood in a river. I know that most of you know the concept of wood in rivers. So, what is a wood in river? Well, basically, we'll see the different sizes and compositions. It could be depending on where we are, the type of river, the type of river dynamics. We'll see three main components. When we want to question the wood river dynamics, so the main component found in the wood budget, which concerns the everything that is recruited within the riverbed, the input into the system, anything which is mobilized and trained or transported during floods, and everything that is accumulated within the river system. Concerning the recruitment, we'll talk about because natural death, trees that will die and will fall into the river, wood that will be caused by the lateral erosion of the banks, and they will then fall into the river and moved, untrained by the river. And then otherwise, in some context, they could be in the Gaspésie Peninsula, where superficial landslide, created a wood volume into the river. Concerning transportation, there could be several modes. Several works have been done in Quebec, in the US, in Italy, and in Japan as well. So different countries worked on the notion of a wood entrainment transport can be by floating traction, by rubbing on the river bed. In some contexts, like here, during in the Waleal there was hyper-concentrated wood associated flow, and therefore cold regions sometimes it could be mixed with ice from the rivers. So, which is what specific we have a log or ice jam. Concerning the accumulation, there could be individual woods. Uh, we talk about just one log. We'll talk about at least a piece of wood of minimum 1 meter long and to at least 10 centimeter. And the jog lamp would be at least three pieces of wood. So you can have jam log very small, with throw pieces 1 meter long, but they could be larger ones, and even getting to the point where the jam logs could be turned into raft, as we see in the east of Quebec. So this is an example of the principle of wood. You see more recent wood that fell into the river, during the last flood, or accumulated wood for about 50 years, for example, in some channels. Now, wood in river and hydrogeomorphology, we know there is a constant interaction which occurs at different scales, space and time space. At the site, at the scale of a site, there will be interaction between IgM and the wood in the river, or it could be a section of a river, or it could be corridors or catchment basins. So different dynamics could take place like this. And temporarily, there could be notions of a trajectory within the system. So that's what I will describe later on. In the Gaspésian systems or the rivers in Quebec, we see an increase of wood volumes in rivers. It is a form of evolution at different time space scales that will cause different dynamics and interactions. Then we know that woods in river will cause uh, ecosystemic and cause possible issues and possibly safety. For example, in some contexts where the jaglob could leave erosion on the opposite banks and cause erosion, and where there is a high accumulation, there could be the raising of the riverbed. The jaglob can also cause inundation in some sector, or there could be a problem also of multi-usage for kayaks. But there could also a lot of ecosystemic advantages. They could have a protection of the banks, where trees will accumulate along a bank, external bank, and will protect the bank from frequent floods and reduce the erosion. It may, in some contexts, we use it in some cases where we'll have a major incision or scouring of the river in case of there is a loss of sediments, or it could be when there could be the breakup of woods. And we know there are links between the aquatic habitats and the presence of wood, and sometimes in rivers, when we can see the presence of wood in rivers, we'll see a higher geodiversity because accumulation of sediments, which will be increased, the presence of wood. There could be flows which will vary based on the presence of wood, and will cause this biodiversity and geodiversity in the system. And it can, in some contexts, mitigate or control the flood peak and recharge the groundwater table. So you see, wood in rivers can actually be positive and negative for a river. Hence, the interest of having a guide on the dynamics of wood, which I will present. So the fact that we know and we integrate everything that has to do with wood dynamics in river and the dynamics of wood in river to give us the possibility to have a better management of the rivers, reduce the risk or potential challenges with and multiple usages. And in the current context, well, the restoration through low-tech processes, and which include reintegration of wood in the river, where we have to know the mechanics, the reintegration, mobility, accumulation of wood that make it possible to have more sustainable or less risk-prone projects in a fairly short time scale. As I was saying, in terms of presence of wood in rivers, the presence of wood uh, could be positive or negative, or could have two orientations. If we look at the scale of the site in terms of hydraulics, that is flow of water, there could be a concentration of a flow in a channel, and or it could this spread span and cause an overflow. This is the case of an analog dam from beavers, but you see the presence of a plunge pool or that could create or a weir could create something interesting. So morphologic presence of wood may cause erosion in some zones, and as we can see here, you can see two jam which cause a concentration of flow. We narrow the flow and cause erosion. Another context where the presence of a log jam may favor the deposit of sediments. And the hydrological, there could be increase or attenuation of the flow rate depending on the environment where we are. Concerning the biodiversity at the hydraulic level, well, we look for fish habitat, and we know the presence of a log jam will create rest zone, feeding zones, and for different life periods of the fish, and development of algae, which will feed the trophic chain. Morphological, of course, there could be overhanging banks or thermal shelter when this could be interesting in terms of reproduction, for example, spawning zones and vegetalized islands and geodiversity due to the presence of wood in there, and everything that has to do with the recharging of groundwater table. But in terms of, we could, the log jam can protect the juveniles during flows as well. Now, when there are wood in the river, several questions arise when it comes to, management. Or more several issues will be around. What are the volume of wood found in the river volumes during floods? What are the mobilization factors for dead wood? The transit time, how long does it take does a tree stay in the river? What are the volume of wood recruited and what are evacuated? And what is the time for decay or alteration and the historical trends of the woods? And these answers make it possible to have a better anticipation of the evolution of the system affected by the presence of dead wood. And I will show you some of the work. As I said at the beginning of my presentation, we've been working on this for about 15 years, and I started that when I was doing my PhD and at QAC, and did follow that at UQAC. So and we worked on the issues, well, this question mainly in the Gaspésie in East Quebec, which is a portion of the Appalachians, and therefore there's rivers with high flow rate and high wood volume, and there could be alluvial forest plains that cover these areas, and with high mobility levels. There is a rare case of the raft of the Saint Jean River. You might have seen it on this, where there clearly we had a specific case of a log jam, which was 3.5 kilometers long at the mouth of the Saint Jean River. So the mobility and significant accumulation of wood may be a challenge for the management of rivers. Motivation, well, two major motivation, scientific ones. Well, it is known that the lack of data or knowledge on natural rivers and natural rivers of medium size, where we were majorly 300 square kilometers, up to 4,000 square kilometers, and even more in the rivers of cold river. So with little work had been done. The validation of the wood budget, what comes into the system, what is mobilized, what is expelled from the system. And of course, this is difficult. And, when you want to work at different space and time scales, sometimes we do wood budget in the Jinxia Dam where wood are pulled out and we know volumes that came in. But in natural environments, it is rare to have uh, which will capture all the wood coming from the catchment basin. We have a limited knowledge on the special tempering dynamics of large wood in river at the And we need to have a better knowledge for the context of restoration, low-tech restoration project or reinjection of wood in rivers, and to have projects which are coherent. Thank you. Now, if we take the scale of Quebec, we do have motivation, local motivation at level of the managers, or there are gaps and challenges identified by local managers for the log jams, and especially for the preservation of salmon. We work in salmon rivers. There is a problem of free circulation of salmonids with the presence of log jam in rivers, and we have to work on management strategies especially when there are major wood raft, which, as I showed earlier on. Another challenge we face in Gaspésia in East, the global increase of wood volume in rivers. Why? Several reasons. End of farming in the 60s, 70s, the stoppage of the wood raft floating, change in the land use and the river use. So there is an increase, quite generalized increase of the wood management and the volume in the river. Now, in the last 15 years, we worked on five main rivers, but I will concentrate on four rivers where we did inter-annual inventory on the four main rivers. When we talk about inventory, inter-annual inventory, we measure all the accumulation of woods found in the river, and we got teams which go on site and will measure the volume of wood. And the student he measures the wood log jams, and we want to see the mobility of log jams and their displacement within the river corridor. Inventory we've been doing since 2010. And in some rivers, we now have 9 inventories carried out. It's a PhD multiple project or PhD, masters and postdoc, and we can work on problem of dynamic of woods at the regional level to understand and try to understand what goes on. Uh, I'll be very brief this afternoon, but we do have several publications in line with, several documents have been published. If we take here at the regional scale, if we look at the 3 rivers where we have the best monitoring, we can see in gray the wood density in cubic meter depending on the rivers. For example, for the small river, Cascapedia, we see the volumes of wood, and associated with the hydroclimatologic events for the Mont Louis as well. We did volumes up to 2,000 cubic meters, you can see, of river. And for the Saint Jean River, you see we work at different space scale Saint Jean, we had monitoring of 60 kilometers, 40 kilometers for Petit Cascapedia, and 12 kilometers for Mont Louis. And therefore, we can work on this notion of flow rate relation between flows and volumes of wood found in the river, which means there is a notion of a wood budget, what is added to the river and what is evacuated from the river. We can also work on the relation better, the time trajectory. We take the volumes of wood for each of the river corridors from correlation, Spearman correlation analysis, where we are above zero, while the trajectory or the volume increase. When we are below, the volumes will drop. So we can see that the relations are different from one river to the next. For example, the St. John River volumes don't seem to increase, or in some sectors it does increase, or so there is more mobility inside. And for the little Cascapedia, you see volume 1 increased almost everywhere in the river. So this is when we look in terms of regional dynamics, in terms of wood volume. So what becomes important when you look at the same type of analysis, but from the number of log jams. So what do we see here? An increase of wood volumes does not cause necessarily an increase of the number of woods. In the St. John River, we can see there is an higher increase of the number of log jams and accumulation, but volumes as such do not necessarily increase. So there is a more distribution, more mobility of woods in this basin, unlike Petite Cascapédia, where the trajectory of the number of log jams tends to drop about the volumes increase. So this is what we see here, is that log jams become bigger, and we got several major structures that will block log to stock the logs, coming from upstream. So this is the type of relationship we can see when we look at the regional scale. So we work on the various hydrogeomorphological variables. You see the increase of volumes in line with the number of log jams. We work also on notions of recurrence flows to you see to 2015 or 50 to 20, 50 years, with the dynamics of sediment entrainment. And we can look also on this notion of a trajectory of systems, including the wood dynamics in this trajectory analysis. For the east of Quebec River, we see an increase of maximum flow rate and recurrence of flow to 20 and 50 years in the last few years since the beginning of the century. We see an increase of erosion and therefore an increase of wood production because of the heavily wooded riparian buffer zones. And more erosion, more woods in the river on the banks, and therefore this explains why we have an increase of the volume of wood and of the dynamic of log jams and interaction, and which can be a problem for some managers when we define this. So we look at this, we can work on the understandings. So, second major point I'd like to discuss today is the major log jam and raft complex we find in east of Quebec, where clearly there are problems of management cohabitation in such context. You see an example here, for example, of this is a major raft on the Saint Jean River, east of the Gaspésie Peninsula. Up until 2015, we had the major log jam of 3.5 kilometer long, 50, 60 meter wide. And you can see the scale of the thickness in some context, some portion of the log jam. It was like a raft. It was downstream. The log jams were more compacted, and it went from the riverbed to the top surface. So it was one of the largest raft found. You can see another image which shows this complex. So this is at the mouth of the river, in an estuary with a braided river, three main channels. You see the main log jam, 3.5 kilometer. You see North Channel with accumulation dated back to the 50s, 60s, and the Central Channel, which is hidden by the vegetation, where we can find another, log jam. Since 2002, we've using this structure of jamming, blocking the woods. And we can see the time dynamics, evolution of raft, but also the woods coming from the upstream. And projects I'm doing in France, we want to work on the notion of androchronology and dendrochemistry. Dendrochronology. Now, just to show you the time evolution, just to show you the various thematics we worked on. Well, as you can see, the RAF from Saint Jean Rivers in 63, it is almost systematic. Every main spring flood, we have the snow rainfall. There will be a major flood when the snow melt, usually April, May, June, and sometimes another flood at fall in line with post-tropical storm coming from the US East Coast. You see, we got almost annual log jams. And you can see from historical satellite images to work on this interannual variability. And we've been able to redefined this construction of the raft from images for the North Channel. You see, was the first portion of a channel, which was the main channel at the time until the 60s, 70s. Then in the 70s, the Central Channel was one of the disposal wood the wood disposal. But since the 80s, you see now we have better space resolution. Here we see we have access to more, in the South Channel, more imaging since the 90s. You can see clearly, you can see the accumulation of woods, the log jams, which are more than 50 year old, found in the North Channel. Now, if we look at the links between the maximum flow rates observed, and we can see the growth of the raft, which vary depending on the hydroclimatic events. When there are high flows, like in 2004 here, you can see high volume here, which will accumulate, and we see the evolution. So I was talking about the stakes here. There is a, there is a management issue. Managers could see that those log jam were caused issues in terms of free flow or the free circulation of salmon. So major dismantling works have been done in 2015. It lasted more than 2 months. You can see here it was done during winter in January, February 2015. You know, to 18, 20 hours a day with a mechanical shovel, and to remove the wood. They were feared that ice bridge would not be long enough to remove all the wood. And you can see all the 1.5 kilometer part of the channel, South Channel, has been accumulated right in the middle of the estuary zone. So major dismantling, but removal, but gives us the opportunity to work on this on the woods which have been removed, and on the reconstruction of this log jam in the context where we remove the wood, but we know that there is the high wood mobility, so the geomorphological conditions are still present in the estuary, but uh, so what do you think will happen when in a context where there's a lot of wood mobility with the same morphology? Well, the log jam is recreating itself since 2016, 17, the first 2 years. Following the dismantling, we had the low flows, limited flow, but you see the cumulative volume of cubic meter of wood, we had almost 12 to 14 cubic meters of wood removed in 2015. Here, a drastic drop when we removed the wood. And you see now we're climbing again with 4 to 6,000 cubic meter accumulated. And the growth of this raft seems to be faster than it was in before the dismantling during the beginning of the raft. This shows you the dismantling here in 2014. The image in 2016 after the dismantling, you see the wood that has been accumulated here. And rapidly, you can see the evolution of the raft here. You can see the first accumulation spot, another one here in the log jam in confluence here. And you see wood, which is accumulating up to here with 4,000 cubic meter of wood. And you see what is at stake, that we left the wood in the middle. Again, in this estuary, well, there is a frequent evolution, and there is a risk of drafting. So I see time is running. So from this project, we went to the project I'm trying to do here with French colleagues, with Brice and Mourid, from uh, and with Annelise Devels, sorry, at the Savoie-Mont-Blanc University. We want to work on the problem of the dendrochemistry, dendrochronology. During the dismantling, we were able to uh, collect about 4 slices of wood to work on the notion of the residence time, the time during which 3 fell into the river and stayed in the river. So it will be mobilized during flood and will be immobilized at the end of the stem. We've been able to collect about 1 tree every 3 linear meters. So, some sectors were easy to access. And from cross the dating analysis that we did in 2017, we were able to work on the year of mortality of the trees. To cross datation, we can go back and to know exactly when the tree died, and we use gross. We work only with the Tuya occidentalis. We have the trees from 1404 to 1982. And thanks to this, we are able to actually, during the growth ring, we can date the trees. And then we know exactly when the tree got into the mouth of the river. And then we can look at the residence time. And a couple of results here. You show that the residence time, you see the residence time mobilized in the river of Gaspésie. The median duration is 3 years between the tree fall into the river and then it is mobilized over 40, 60 kilometers, very fast. Only 3 trees at a higher residence time, 100 years and the oldest tree which had been out of the stem was 172 years, and 64% of the trees had a residence time lower than 5 years. So it is, we were able to go, we want to work again on the wood budget. So you see new collaboration with dendrochemistry in France because we know the reason time we don't know where do the trees come from in the catchment basin. So but through the dendrochemistry, at the beginning we had more or less 400 slices. So now we got about 200 that we got when we built the new raft in the last few years, and we are now building a series from living wood core to sample to use a copper mine, which was operating for about 40 years to see if we could not use the what came out of this copper mine and see if we can find it in the wood, because there would be pollution, copper pollution. So we can see the concentration of chemical elements coming from the mine on the 600 slices of dead wood to know when they die, but also from the series on the living trees and the concentration of various biogeochemistry that we can do. But are we able to know within the catchment basin when the trees come from? So this is being developed, and the first test will be done beginning of February. We are preparing the samples right now, and we are working with Brice Bourrier on these issues because we know the notion of footprints, environmental footprints, and so on that we could detect within the different rings of the trees, edge rings of the trees. They should have, or growth ring, we should have results soon. I've shown you the Saint Jean River. Another case I could show you of major log jam, the river, the Port Daniel River, which is about 100 kilometers from the Saint John River where we were. So what I want to show you is rapidly is to show you the evolution, the trajectory between the system up to the year 2000, which has been maintained. There was agriculture, and the farmers would maintain a main channel. And basically, you see the human impact was seen at this level. And and then we were called in 2010, 15, 16 to work because managers had fears about the presence of woodlog jams, or beaver dams, which would impact the free circulation of fish. So we did a diagnostic analysis of a wood budget, and what we could see that as of 2004, 2005, when we stopped maintaining the main channels and stop erosion in some domains. Well, basically, the return of log jams, the beavers, closed a braided system naturally with no works for restoration work. So, of course, the system sort of self-restored itself due to the presence of log jams brought by the evolution creation of new channels and beaver dams, which accelerated the process. It's interesting to look at that. Now, I'll look at the rapidly at the ice dynamics, but I might redo a presentation later, but just to show you exactly what it looks like, dynamic of mechanic dynamics of ice with the impact it has on wood transport. You see, sorry for the quality of that image, but you can see the woods, the logs, transported by the ice, the fragmented pieces of wood. It was a ice corridor on the river, and with an increase of the flow rate, they were transported. Another example in another river, it's the Cascapedia River. You see, Mastapedia, sorry, we see on wood recruitment to show you the force and the impact of those ice breaking up. You see where woods, you know, woods are completely crushed and taken into the river and trained into the river. So the ice is to be, the dynamic of ice is important because it has a high morphological impact, which is worrying because we work on these issues. So we worked on this transport of wood, entrainment of wood, where clearly we quantified the number of logs going every minute in a context with mechanic. Or what's also interesting when we got mechanical breakups, the flow rates will be limited, but water level will increase rapidly because of the presence of ice. For a flood in 2012, the flow rate was about 30 to 50 cubic meter. We had would transport over 15 logs per minute versus ice-free floats, where we see that 1.4 log per minute for a float of about 200 cubic meter, up to 10 log per minute, again with 250 cubic meter float. So difference of almost 200 cubic meter of wood volumes are different, when we have ice at low rate. And therefore it complicates, when we want to compare this with work done in France with the presence of cameras, but, there's something specific. We work on also the notion of on the link between the ice breakup and wood breakups. And we have a student who started in September, Samuel Laroche. We work on these questions of log jam and ice jam. So quickly, I want to go to the guide, wood guide, because I think it's interesting, and maybe there could be potential collaborations to apply this guide to Quebec. So you see, concerning the management in Quebec, like everywhere in the world, there is a negative perception of log jam, but it remains. So we published a guide on wood in river dynamics, and we do have surveys, and the result of a survey done before the guide and 2018 before the guide and after the guide. And we realized, firstly, well, we see that the large wood perception in the river is even more negative at the end. So it's not necessarily in line with the diffusion of the guide, but simply it's in the number of years during which managers have to deal with in the organization that work on the management of woods in rivers, what trainings must be maintained, done more frequently, because when the guide was published, there were several presentations done. There were several trainings as well. So this shows us that we have to keep sharing our knowledge and disseminate the guides or give training, because there is rapid evolution, at least in Quebec, of the uh, employees in this environment. So after 2018, We understood the management, the needs for the managers. They would take a guide of healthy practice for wood management in rivers to integrate the hydrogeomorphologic, biological, and civil safety aspects. And there was a need to identify if a logjam is a problem or not. This is the decision-making support matrix. Where does the wood come from? Is it environmental anthropic reasons? Is it still a problem? And then there was a need for the managers. So we developed this guide in 2019. It was republished again in 2022. You see the summary. If you want to, the QR code, you can jam the QR code or write to me, send me a message. This will be available on the web. And we address questions of management of wood in river, hydrogeomorphology, notion, role of wood in rivers, global influence of wood in river systems, case studies we did in Quebec, and clearly, it is quite a basic knowledge guide, which will leads to decision-making support metrics. We have a matrix which is on Excel, easy to access, accessible from this QR code, where the ed decision this decision-making support tool based on several elements that will come, several questions that will make it possible analyze the river dynamism index or the wood dynamic index. So what type of river environment, type of banks, what are the historic change, is there mobility, type of river, type of flows. Likewise for the wood, what is the ratio of channel jammed by threes, percentage obstructed, presence of logjam works as bank protection. Does it cause erosion? What's the density? What's the trajectory? And therefore, we can, in this, by answering the question, you get to a river dynamic and this index of zero point 0.7 or zero point 0.6. So this is a zone where basically monitoring and studies to be considered when the river dynamics is such that logjam could become problem versus if we were in this case, well, it should be maintained. So you got four indices, and everything that has to do with the civil security and the habitats. Again, same principle. And that did create, a deeper zone, create shadows under shade on the river, riparian habitats, creation of riparian habitats. And you say we answer several questions, and that will make it possible to get to this notion. It does not give you 100% answers, but with all the indices, it enables the managers to ask themselves questions about the river dynamics, the wood dynamics in rivers, the importance of all the ecosystemic advantages and all the challenges and stakes. So it is something that can help in the decision-making process, and also in a context when you want to introduce wood in the rivers, we can do it in this context to see if the log jam could be a problem in medium term, and maybe that could lead to new analysis or examination. So it could be interesting to see. We apply it in Quebec. We had some feedbacks from managers. Is it applicable in France? We never tried it. Could be a good question, an interesting question to study, to work on these notions. So I will close with those elements to my plus minus 40 minutes, but very much like in France, I was involved in the 2 days organized by Clara on the low-tech restoration. We do that in Quebec in this trend of natural process low-tech restoration. So several projects are in progress right now. Several projects done by and it's mainly small agricultural rivers with issues of river banks incisions. We want to reintroduce wood in the rivers to reduce the incision. So the partnership is being done to work on the issues of durability of infrastructure, efficacy, mobility on the long term. So they are RFID monitoring, video, time-lapse morphometry, and morphologies that should be implemented in a partnership with several ministries in Quebec. This was in the little rivers, but we also have projects in larger rivers. And we work on some rivers which have been linearized for the transport of wood and what the driving. Then now they will reinsert wood to see different types of log jams, anchored, unanchored, and we will use also telemetry to do interannual monitoring. There will be 3 restoration sites that will be installed in 2030 in the Escoumene River, on the North River of the St. Laurent River, with interannual monitoring till 2035 in partnership with WSP and Quebec to work on these issues of durability, efficacy, mobility of structures, and associated risk. So these are the questions we will be working on in the next years with multiple projects in progress. As you can see in our teams, mainly at UQAC and UQAR, you see, so we work on the perception in line with beavers. With we've published an article on this notion of management of beavers in Quebec. Several projects came from the several colloquium we organized in the Wood in World Rivers 5 in Gaspé. So several projects in wood dynamics in our teams in Quebec, and we are getting ready for Wood and World River 6 in Australia. That should take place in 2026. 28. I'm slightly over time. I hope I didn't go too fast at the end. So if you have questions, on the wood dynamics, this is my work on the, restoration of process, habitats, aleutic habitat, and so on and so forth. Well, we have a great team in Quebec, you see, with several, students, so researchers, 2025 UQAC, who are, work on this for the environment of rivers. So thank you all. And without them, thank you to them, because without them, research was not possible. So thank you. I'm open to questions. Thank you, Maxime. Well, we do have a lot of questions. So, Kevin, should you start with your question on the guide and the applicability in France? Thank you, Maxime. I have a question. Well, you talked about it. It's difficult to know if this decision support tool would be very useful in France, but it's difficult to know if the tool you developed could be adapted to France, or maybe we would have to change or bring in modifications. It can be adapted in most environments. The guide was developed in the development of the Appalachians, gravel river, high energy, high slopes, steep slopes. We also work on the new morphology for the alpine context in Quebec, where we realize that it does apply well. So I'm quite confident that this index could be, well, I'm sure there are questions that could be on the glacial dynamics. There is no ice in France, but uh, very much like the morphology quality, if we remove parameters, the calculation will be reevaluated. So we can remove questions that are not applicable for the environment, but to me, it would be applicable in France. So I'm sure we could test it. Absolutely. To be followed. Thank you. Antoine is asking, is it possible to assess the quantity of natural wood before the entropic action? Uh, what would be the natural quantity of wood? Well, in our systems, We are mainly in almost, well, we said uh, so got 95% of wood came from very little wood in our raft coming from uh, uh, cuts or for heritage from the old forestry. So almost 100% natural. So those are estimations done in some breakups, but we can see, or log jam, but we can see where the root system that is present, or there is no trace of cuts done by foresters. So it's mainly wood coming from natural processes. To you, it can be comparable to the quantity of woods we could have over thousands of years or hundreds of years. It's a good question, actually. We don't have data, but we have access to notebooks from land surveyors or explorers dating back to the major explorations in the North American continent. So the English king wanted this ask his subject to describe the landscape, and for the raft of the Saint Jean River, the huge raft I was saying, already in 1840 there was an 800-meter raft, in the middle of the river. So I do believe that currently we should be in volume, which are quite similar, especially for the east of Quebec in Gaspésia, where you got 50,000 inhabitants in the territory, which is, which is a huge territory. So very little anthropic impact in this environment. There is protection of banks, which is very high. So in our environment in east of Quebec, it could be we can see what can be expected in a natural system versus other systems closer to major centers, closer to Quebec or Montreal, where there could be wood volumes that would be lower to what we had historically. So it's what's interesting to look at in rivers. Well, we want to see what we could have. I mean, there are perturbations, where what is closest to the natural rivers. Yes. Second part of the question, the speed of the decaying of wood, the decaying rate of wood, how the speed. Well, we haven't worked on the composition of decaying of wood. Works have been done by colleagues in the US in various environments, tropical environments versus other environments. So indeed, there can be in forestry, it's common to have values of wood decaying rates in the Nordic environment when temperature are fairly cold over 4 to 6 months a year. The decaying rates are slower in our systems, but it not so obvious in our systems. Trees are rapidly buried rather than decayed or decomposed, or different from tropical or hot environments where decaying will be faster on the wood budget. So we considered that the decaying rate in our environments is such that when it comes to loss of volumes within the wood budget, it called for a lot. We know it needs to a lot of effort to work on the decomposition of wood, and it's we don't need to work on this because the decaying rate are weak, and we don't need to invest time and money. And then we are in environments in such rivers, but certainly Tuya occidentalis, which decays even more slowly than other trees. But in some contexts, indeed, it is necessary to take this notion into account of wood decomposition within the or in the wood budget. Another question from Clément on data concerning the migrating fish. Ecological continuity, especially for the raft, when you see such a huge uh, log jams or rafts, we can question that. And the presence of beavers mentioned, I don't know if you have done study there. Yeah, well, for the Saint Jean River with the 3.5 kilometer raft, telemetry project was done in 2009, 10, 11, where we observed that salmons Atlantic salmon in the Saint Jean River. It took them 15 to 30 days longer to swim up the Saint Jean River versus the other rivers, the York, Dartmouth, where it is faster. But there is no data before the presence of the raft or the log jam. So it's difficult to be certain that this is the raft or the log jam that we have a real impact in a context where we are in braided environments as we see on the Saint Jean River. There are channels almost everywhere with seven, eight, nine channels. So salmon will always find a way. So there is no real challenge. Now, if we take the second case I presented on the Paul Daniel River, where it's the same thing, there are always channels available or sectors where the salmon can use or trouts as well. For the beaver dams, we worked on this, but not in Gaspé Bay, other rivers, in the Ware River. And we realized that for a certain period of time, there could be a blockage. But we followed five beaver dams. And in the five beaver dams we monitored, there were always periods which hydrologically speaking, were uh, facilitating the uh, the uh, the migration of fish, various species of fish during the hydrological period, and therefore it was not a total challenge. There was always a time where fish could go from upstream, downstream, so it was not a problem for a period of 1 year in terms of hydrology, at least. Clearly, what do we do? We beyond 6 o'clock. Okay, Alex, is your guide available in English? There were discussions for colleagues from New Brunswick on the, I guess maybe to do translation, but short term, it's not in the plans. We'd like to translate it. US guide, I think, on Woodin River, which is quite well. There are other guides, of course. There's also a guide in the last few years. Our guides can be complementary, or with indeed in the US. There are two guides which exist in English and which could be maybe could help. Raphael wants to know the fact that you removed the huge raft on the river, you dismantled everything. It talks about the estuary, but was there a major reason for that, or was it justified to break everything to remove it? Well, we did more detailed monitoring following this. I could say that the decision made for the dismantling was more political or perception in the context where during several years, the managers of the river that the raft would block the free flow of salmon. They were tired when they got to the river. The fishing in the salmon fishing industry is very, important locally for local economy, and therefore, the raft was damaging this. So there were less fishermen going to the river, less income perception. Also, the fact that they didn't have any, you know, uh, sound data saying that yes, indeed, the raft would have a negative impact on salmon population. So it was more this political decision. So associated with a perception, you know, on our side when we were asked for our opinion. I can go into detail, but on the mouth of Saint Jean River, we can see that there is an avulsion between avulsion are changes of quick uh, path of creation of new channels. And this is very classic of a braided or meandering environments where there are always new channels that will appear or come up. Well, once the channel has been completely blocked at the beginning, the creation of a new channel, and automatically the system is auto-regulated and creates a new channel quite rapidly, but the measures decide to move forward, and therefore I don't know if it answers your questions, but anyway. Well, it makes it possible for us to work on this notion of dismantling, and we work on the morphological impact, and so we want to see what are the variations done, so we can better understand the major dismantling, the impact they have on the rivers. Most interesting. Well, we don't see this kind of accumulation on our rivers, so it's interesting. So I think we've covered the questions clearly. So yes, indeed. So thank you, Maxime, for this very elegant presentation of your work and for this discussion. Do not hesitate to contact Maxime and take advantage of the fact that he's in France until July to exchange with him. Thank you, Kevin, for being the facilitator. And of course, so we thank you to the translators as well. So thank you, Maxime. Maxime, do you want to say something? So, so the wood and river is quite a hot topic in France right now. So, it will be interesting to move forward on these subjects, which are very fully action. Great a pleasure to collaborate with you. You could put my email. We'll put Maxime. What we see that questions are asked. There is a progress. Quebec is ahead of us. So it's interesting. Thank you, and it's it's a quite fascinating subject.